Pretty much every company out there wants to be data-driven, but there's this huge nagging problem. All that incredibly valuable data, it often just ends up in this messy, unusable data swamp. So how do you fix that? Well, today we are going to walk through how to build a modern data lakehouse, and I mean really transform that swamp into a high-performance foundation that you can actually trust. So here's how we're going to break this down. First, we'll tackle the fundamental dilemma that got us into this mess. Then, we'll lay down an unbreakable foundation, build on top of it with reliable bricks, and then figure out how to make it super fast and smart. After that, we'll lock it down with security and governance, and finally, get the whole thing running like clockwork. All right, let's dive right in. We have to start with this fundamental conflict that, honestly, anyone who's worked with data for more than a week will recognize. For the longest time, you were forced to make a really painful choice. And this question gets right to the heart of it. The old school data lakes were amazing because they were so flexible, right? You could just dump any kind of data in there, structured, unstructured, you name it. But that amazing flexibility, well, it was also their biggest weakness. It came at a huge, huge cost: reliability. And for years, this was the trade-off. You really had two camps. In one corner, you had the data warehouse. It was structured, trustworthy, super consistent. But man, was it rigid and slow to adapt. Then in the other corner, you had the data lake. It was flexible, it was scalable, but it was so prone to becoming that dreaded data swamp, where you just had no idea if you could trust the quality, and having multiple people working at once could lead to total chaos. You basically had to choose. Do you want it safe, or do you want it fast? So this is where things get really interesting. A single innovation comes along and just completely shatters this old trade-off, finally giving you the best of both worlds. It all starts by building an unbreakable foundation right on top of the cloud storage you're already using. And here it is. This is the secret sauce: ACID guarantees. Now, this is a concept that's been borrowed from the world of traditional databases, and it's what ensures your data operations are rock solid. Atomicity means a transaction is all or nothing. It either fully completes or not at all. Consistency makes sure your data is always in a valid state. Isolation means multiple jobs won't step on each other's toes. And durability? Well, once a change is committed, it is there for good. This brings a level of trust to the files in your data lake that was just impossible before. So how does this actually work in practice? It's a beautifully simple idea, really. Under the hood, Delta Lake maintains this transaction log. So when you go to change some data, it doesn't even touch the old files. Instead, it writes out new files and adds a tiny little commit file to the log that says, hey, here's what changed. That commit is atomic. It's all or nothing. So anyone reading the data sees either the version before the change or the version after. They never ever see a corrupt, halfway done state. It's just like your bank's ledger. It's an immutable record of truth for your data. But what happens when multiple teams are trying to write data at the exact same time? This is where things get really clever. Instead of using slow, old-fashioned database locks, Delta Lake uses what's called an optimistic approach. Basically, it just assumes that different jobs won't conflict with each other. When two jobs try to commit at the same time, it does a quick check. If there's a conflict, like they both tried to change the same file, one of them fails and just has to retry. This lets all your teams work in parallel without constantly tripping over each other. Okay, so we've got our rock-solid foundation in place. Now we can start building some powerful, structured data pipelines on top of it. This is where we go from just storing data to actually refining it and creating real business value. The medallion architecture is this simple but incredibly effective pattern for organizing your pipelines. Data just flows through three distinct layers. First up is the bronze layer. This is just the landing zone for your raw data, exactly as it comes from the source systems, warts and all. Then in the silver layer, we start to clean things up. We validate the data, conform it, maybe join a few things together. And finally, the gold layer. This is the polished prime-time data. Business-level aggregates, tables ready for your BI dashboards, and machine learning models. It's this multi-hop pattern that progressively improves the quality of your data. Now, that all sounds great, but you might be thinking, how do I keep these bronze, silver, and gold tables in sync when the original data changes? In the past, this was a complete nightmare. Well, the solution is the Change Data Feed, or CDF. Delta Lake can literally track every single row-level change, every insert, update, and delete. So you can just ask it, hey, what's new since the last time I ran? This makes propagating changes from one layer to the next incredibly simple. It's a total game changer. Okay, so now our data is reliable and it's high quality. But none of that matters if your users can't query it quickly, right? If it's slow, no one will use it. So the next piece of this puzzle is all about performance. How do we make this thing fast? I mean, when you're dealing with terabytes or even petabytes of data, you can't just scan through everything every time someone runs a query. It would be way too slow and way too expensive. The answer is to organize your digital files intelligently, just like you would organize a physical library. And two key techniques here are partitioning and Z-ordering. Think of partitioning like organizing a library by genre. If your data is partitioned by date and you ask for last week's sales, your query can just completely ignore all the data from previous years. It doesn't even have to look at it. Z-ordering is a more fine-grained technique. It's like organizing the books on each shelf by author, clustering related data together inside each file, making it even faster to find exactly what you're looking for. But there's this silent performance killer that can just cripple even the best designed systems, the small files problem. Streaming data, especially, tends to create thousands and thousands of tiny little files. And just the overhead of reading the metadata for all of them can bring your queries to a crawl. The fix, it's almost ridiculously simple. A single, powerful command, optimize. It just compacts all those tiny files into fewer, larger, more efficient ones, and boom, your speed is back. So our platform is reliable, it's structured, and it's fast. Now we have to talk about something that's absolutely non-negotiable: security and governance. This can't be an afterthought. It has to be baked right into the core of the platform. This is one of the most critical questions you'll ever face in data governance. How do you make sure an analyst can see customer data but not their private salary information? Or that a manager for one region can only see sales data for their own territory? The platform gives us a really elegant answer with a feature called dynamic views. And this is where it gets so powerful. You define a single view on a table, but the data that actually comes back depends entirely on who is asking. Just look at the slide. An analyst runs a query, and the salary column is masked. An HR manager runs the exact same query, and they see the real number. It's one table with one set of rules, and the security is automatically enforced right at the moment someone tries to access it. All right, we've made it to the last mile. We need to talk about taking this entire beautiful system and making it run reliably and automatically in production. Because a great design is only useful if it's operational, right? To make this all happen, you need the right toolkit. First, you've got the Spark UI. Think of this as your detective tool for hunting down performance bottlenecks in your code. Next, Databricks Jobs is your orchestra conductor. It orchestrates all your complex workflows so they run flawlessly and on schedule. And finally, the CLI and APIs. This is your automation engine. This is what lets you plug your entire platform into modern CI/CD pipelines and manage it as code. And that brings us to the final and, I think, most important question. When you combine the reliability of ACID transactions, the clean structure of the medallion architecture, the speed of smart optimizations, and the safety of fine-grained security, what have you actually built? It is so much more than just a better data warehouse. You've built a single unified foundation for everything that comes next, for data science, for machine learning, for AI. You've truly turned that data swamp into an innovation launchpad.